person purchases a television set for rupees 16,000. First doubt. If its life is estimated to be 20 years and the yearly depreciation is assumed to be constant, find the rate of depreciation and the price after 8 years. Okay. In this, rate of depreciation means in rupees. How much does it depreciate every year? And what will be the price of the TV after 8 years? Okay. So if a person purchases a television set for rupees 16,000, means its initial cost can be assumed as A. Why? As it is given that if the yearly depreciation is assumed to be constant, means it is decreasing constantly, means it is forming an AP. So its initial cost can be estimated as the first term of the AP. The initial cost can be estimated as the first term of AP. Depreciation is constant means it has a common difference. As we must write depreciation is constant, hence it's an AP. And we have to find the common difference. Its life is estimated to be 20 years. What does it mean? It means after 20 years, it has some value. But on 21st year, its cost will become 0. It has some values till 20 years. But on 21st year, its cost will become 0 when its life is estimated to be 20 years. Means on 21st year of its production, its cost will become 0. Means 21st term is 0 when the first term is 16,000 and depreciation is constant. Now if we use the formula for general term of an AP, which is AN equals to A plus N minus 1 into D. And if we substitute 21 in place of N, 16,000 in place of A, N 21 minus 1 into common difference is D, which is unknown and constant. Now 21st term is 0. After decreasing constantly for 20 years, on 21st year, its cost becomes 0. Plus 20D, it implies minus 20D equals to 16,000. If we transfer this 20D to the next side, D equals to 16,000 upon minus 20. 0 cancelled out, it is minus 800. So the depreciation is 800. Depreciation is, we have to find it in our question, find the rate of depreciation. So we write depreciation is rupees 100 per annum. Then also find, in first we have to find the depreciation, and the price after 8 years means we have to find a price after 8 years when initially in 0th year its cost is rupees 16,000. After 8th year means 9th term. After 1 year it will be second term, na? 16,000 minus 8, 15,200 will be the cost after 1 year. So after 2 years cost will be decreased by 2 into 800. After 3 years cost will be decreased by 2 into 300. So after 8 years, it means 9th term. cost after 8 years means on 9th year. That is cost in 9th year. After 8 year, 9th year will begin. So we have to find cost in 9th year. A9 equals to A plus 9 minus 1 into D using the same formula. An equals to A plus n minus 1 into D. Okay. A is already given 16,000 plus 8 into rate of depreciation is we use minus 800 as it is the depreciation. We already have written depreciation. That's why we have not used minus sign in this slide. 16,000 minus 8 is a 64, 6,400 equals to rupees 9,600. So cost after 8 years, that is on the beginning of 9th year, is rupees 9,000. And so next doubt is in a question related to logarithmic theory of logarithms. So I am discussing some of the formulas of log, though you have studied them in lower classes in class 9th. The first formula, or we must say, is the method to convert a log into indices into log, and log into indices. So how to convert an indices to log? This is by using the formula if a to the power x equals to b. Remember, this a will remain in the base. This time we have to write it as log b to the base a equals to x. Okay. This is how we can convert an index to a logarithm. A to the power x equals to b. It implies log b to the base a equals to x. Second important property. We are not discussing log this time. So I am directly telling you all the properties. Log a to the base c plus log b to the base c. We read it as log a to the base c plus log b to the base c equals to log ab to the base c. Third property, log a to the base c minus log b to the base c equals to log a by b to the base c. Fourth property of logarithm, log a to the power m and base is still c. Mostly when no base is there, we use 10 or e as the base. Log a to the power m base c. In this question which you have asked, the base is 3. Log a to the power m base c equals to m goes to the coefficient. M becomes the coefficient. M log a to the base c. This is the fourth property, which is also very. Fifth property, log a base b equals to log a upon log b. This can be also called as base change formula, as in this we can change another base which is given in the question. Base was b, but this time we have taken it to be c. Log a base c to the log b base c. Write all these properties and learn them. They will be used in many questions. Then log a base b equals to, we can also write 1 upon log b base. Seventh property, a to the power log b, the base c equals to b to the power log a to the base c. Okay. So repeat all these property once. If a to the power x equals to b, which is the first property, then log b base a equals to x. Second property, log a base c plus log b base c equals to log ab to the base c. Third property, log a to the base c minus log b to the base c equals to log a by b to the base c. Fourth property, log a to the power m to the base c equals to m into log a base c. Fifth property, log a base b equals to log a to the base c over log b to the base c. Sixth property, log a base b equals to 1 upon log b base a. Seventh property, a to the power log b base c equals to b to the power log a to the base c. Okay. Eighth property, a to the power log x to the base a equals to x. This property will also be used in many questions. All the properties actually will be used. Okay. But some properties are used more than the other property. This is one of them. This first, second, third properties, fourth properties are used mostly in the questions. And the next is this, a to the power log x base a. Both the bases are a, so the value is x. So these are the properties of log in short, which you have to learn on these. Okay. Then we go to our question. If log 2 base 3, log 2 to the power x minus 5 base 3, log 2 to the power x minus 7 by 2 base 3 are in AP. Remember, log a to the power base a to the base a equals to 1 means base and exponents are same, that the value of logarithmic will be 1. And if there is log 1 to the base anything, its value will always be 0. Okay. So after writing all these properties and understanding them, we can solve the questions related to log. Now we can solve the questions related to log. Like this question. If log 2 base 3, comma, log 2 to the power x minus 5 to the base 3 and log 2 to the power x minus 7 by 2 to the base 3 are in AP. We know that if A, B and C are in AP, then recall the property. If A, B, C are in AP, then what is the relationship between them? We have discussed all the properties of arithmetic progression in previous sessions. So we know that if ABC are in AP, then twice the mean equals to sum of extremes. Now mean is log 2 to the power x minus 5. So 2 into log 2 to the power x minus 5 to the base 3 equals to A is the first term, log 2 base 3 plus third term is 3 log 2 to the power x minus 7 by 2 to the base 3. It implies now this coefficient of log goes to the power using this property. Log a to the power m base c equals to m log a base c, and converse is also true, means m log a base c. If m is the coefficient, it can be written on the power of a. So it is log a to the power m base c. Similarly in this, 2 is the coefficient of 2 to the power x minus 5 log 2 to the power x minus 5 base 3. So it becomes the power of 2 to the power x minus 5, base remains the same, equals to, now in this we will use the property log a plus log b equals to log ab. Second property, log a plus log b equals to log ab. So we write log a b. So log can be removed from both the sides. As both of them are log, so they will be cancelled out. 2 to the power x minus 5 whole square, and both have the same basis also. 2 into 2 to the power x minus 7 by 2. Okay. Now there is only 2 to the power x. So to solve it and to simplify it, if we put 2 to the power x equals to y, the equation becomes y minus 5 whole square equals to 2 into y minus 7 by 2. It implies y square plus 25 minus 10y equals to, open the bracket, 2 into y minus 2 into 7 by 2, 7 only. It implies y square plus 25 minus 10y minus 2y plus 7 equals to 0. It implies y square minus 10y minus 2y minus 12y plus 25 plus 7, 32 equals to 0. Now factors of 32 whose sum is 12, we know that 8 fours are 12. So we write y square minus 8y minus 4y plus 32 equals to 0. It implies when we take y common from first two, y into y minus 8 minus 4 common from next two, 4 into y minus 8 equals to 0. It implies y minus 8 is common from these two terms into y minus 4 equals to 0. It implies either y minus 8 equals to 0, that is y equals to 8, or y minus 4 equals to 0, that is y equals to 4. It implies either 2 to the power x equals to 8 can also be written in powers of 2s 2 cube, or 2 to the power x equals to 2 square. It implies either x equals to, comparing powers both sides, x equals to 3 or x equals to 2. So when we write either x equals to 3 or x equals to 2, we have to check whether they are satisfying the given equation or not. First term is log 2 base 3. Second is 2 to the power x minus 5. If we use x equals to 2, it is 2 to the power 2 minus 5. That is 4 minus 5. So it is log of minus 1 to the base 3. The negative logarithm is not defined. So this 2 is inadmissible. Value of x as 2 is inadmissible. Why? As it is making the log negative, which cannot be taken. Means x equals to 3 is the only one answer to this question. When log 2 base 3, log 2 to the power x minus 5 base 3, and log 2 to the power x minus 7 by 2 base 3 are in AP, then x equals to 3 is the answer. Is the only solution to this question. X equals to 3. Understood? If three terms are given, log 2 base 3, log 2 to the power x minus 5 base 3, and log 2 to the power x minus 7 by 2 to the base 3 are in AP. As we have studied the properties of arithmetic progression, that if three terms ABC are in AP, then twice of mean equals to sum of extremes. So mean is log 2 to the power x minus 5 base 3. So 2 into log 2 to the power x minus 5 base 3 equals to A means first term log 2 base 3 plus C means third term is log 2 to the power x minus 7 by 2 base 3. It implies now this 2 goes to the power of 2 to the power x minus 5 using the property m log A equals to log A to the power m base C. So log 2 to the power x minus 5 whole square to the base 3 equals to log, in this log A plus log base log AB base C. So 2 into 2 to the power x minus 7 by 2 base 3. So taking anti-log both sides, removing log means taking anti-log both sides to the base 3, this log will be removed. So only the terms without log will be written. 2 to the power x minus 5 whole square equals to 2 into 2 to the power x minus 7 by 2. Now if we put 2 to the power x equals to y both sides, y minus 5 whole square equals to 2 into y minus 7 by 2. It implies, now expand the bracket, y square plus 25 minus 10y equals to 2y minus 7. So when we transfer all the terms to the same side, y square minus 12y plus 32 equals to 0. Now if we find the factors, y minus 8 into y minus 4 equals to 0. So either y equals to 8, y we have taken as 2 to the power x. So 2 to the power x equals to 2 cube, which is making x equals to 3. or 2 to the power x equals to 2 square, which is making x equals to 2. But this 2 is inadmissible. Why? As it is making 2 to the power x minus 5 as 2 square minus 5, 4 minus 5. Log minus 1 is not defined. You can write the reason, though it is not required to write, as it is making log 2 square minus 5 base 3 equals to log minus 1 base 3, which is not defined. Okay. So after this question, now we will discuss the other doubts. So the next doubt is from the theory of series and sequence. Fifth second, 6, 9, 16, 27, 42 are in a regular series. So what will be the next term? So think about the difference. 3, 7, 11 and 15. So if you watch, these are also in AP. So what will be the next term of AP if you add 4? 15 plus 4, 19. So we have to add this 19 to the 40, to 42 plus 9, 61. Like 42 plus 19, 61 must be the next term. You can solve using this method all the questions related to these types of series. Just like in next, third part also I am discussing, though you have asked only second part. 1, 5, 14, 30 and 55. Find the differences. 4, 9, 16, 25. So what is this? These all are the squares of natural number. 2 square, 3 square, 4 square, 5 square, 6 square must be in the next. Means 36, 55 plus 36, 91 is the next number. Hint was given, and that's why you have noticed. Okay. Similarly, we can use the first also, though it is very easy. 0 plus 2, 2 plus 4, 4 plus 8, 8, 4 plus, 6 plus 6, 12 plus 8, so 20 plus 10, 30 will be the next. Okay. This is very easy to find the next term if we solve it by this method. Question number first, 6 is the next doubt. 10th term of the sequence. We have to find the 10th term of the sequence. Root 3, root 12, root 27 and root 48 and so on. 10th term. So first change them to mixed shirt form. Factorize 12. 2 6 are 12. 2 3 are 6. 2 is in pair. So we write 2 root 3. Find the factors of 27. 3 into 3 into 3. 3 is in pair. So it is 3 root 3. Factors of 48 are 4 into 4 into 3. So it can be written as 4 root 3 and so on. So first term is root 3. Check the difference of next two terms. A3 minus A2. 3 root 3 minus 2 root 3 same as 3x minus 2x is x. Similarly, 3 root 3 minus 2 root 3 is root 3. And the first two, A2 minus A1. 2 root 3 minus root 3. So it is also root 3. So difference is common. So it's an AP. Okay. And how to find the nth term of an AP? By using the formula A plus n minus 1 into D. A is root 3. We have to find the 10th term of this series, of this sequence actually. 10th term is n equals to 10. So 10 minus 1 into common difference is root 3. So root 3 plus 9 root 3 equals to 10 root 3. Very easy. You can find if you continue to write 5 root 3, 6 root 3, 7 root 3, 8 root 3, count 1, 2, 3, 4, 5, 6, 7, 8, 9. Finally, 10 root 3 is the 10th term. First root is 1 root 3, second root term is 2 root 3, third term is 2 root 3, 10th term is 10 root 3. We can directly write. So these are the tricks which we must use in solving the objective questions. I will give you the sheet of objective questions also after some time. After the complete discussion of the chapter, we will discuss the objective sheet also. And then question number third first, which is related to the properties of logarithm. If AB are positive real numbers, so that the sequence log A square by B, log A cube by B square, log A to the power 4 by B cube is also an AP. So find the common difference, find the difference actually to check whether it's an AP or not. First, if we find D equals to A2 minus A1, so A2 is A square by B and A1 is log A. So log A square by B minus log A equals to log A square by B divided by A equals to log A square by B. When we change divide to multiply, it becomes 1 by A. One of the A will be cancelled out. So D is equal to log A by B. Okay. Then we find D again by using A3 minus A2. A3 is log A cube by B minus A2 is log A square by B equals to log A cube by B divided by A square by B equals to log A cube by B into B by A square equals to B cancelled out, A cube by square is A. So log A. It is A cube by B square actually. A3 is A cube by B square. So log A by B. So difference is common. So it's an AP. And now if it's an AP, we can find the nth term by using the formula for general term of AP. N equals to A plus N minus 1 into D. A means first term, that is A1, which is log A, plus N minus 1 into common difference is log A by B equals to log A. Now this N minus 1. What should we do with this? First, we transfer it to the power. Now we can use log A plus log B, which is log A into B equals to log A is in the numerator into A to the power N minus 1 upon B to the power N minus 1. And in multiplication, powers are added. So 1 plus N minus 1, 1 cancelled out. A to the power N upon B to the power N minus 1 is the nth term of this AP. This is the nth term of the AP. Log A to the power N over B to the power N minus 1. Means power of A is always 1 more than the power of B. Power of A in the numerator is 1 more than the power of B in the denominator. Everywhere. So in nth term also it's the same thing. Power of A is 1 more than the power of B in the denominator.